the main thing, how to write a Verilog program. Verilog program consists of mainly two blocks. We can write the Verilog program. It is classified it into two modules. One is the main design module. We can call it as the design module, which describes what is there in the particular logic. And to test that particular logic, we are going to use another module called as Testbench module. So, Verilog program is divided into two, where we are going to have a module which describes the circuitry, and to test the particular module, we are going to have the test bench. So, two programs are required. So, when we are going to write a module, it has certain syntaxes. We have to follow those syntaxes. Module, this Verilog is a case sensitive. All the keywords that we are going to use should be written in small letters, using small letters. So here we are going to have the module, input ports, output ports, and how to declare a module. Let us see with an example. So this is an example that shows the syntax for the module. We are going to define the module by the keyword called as module. Module name may be anything. Within the braces, you are going to have the port list. Port list, it may have, you are going to describe the output ports, first of all, followed by the input ports. So after declaring the input, output or in-out ports, you are going to describe the particular logic at 4 different levels. Either you can use the gate level, switch level, data flow, or behavioral, or you can have the mix of any of these. Then, starting with the module, you have to end the module by its name. So, end module. So, this is the syntax for writing the design module, not for the test bench. So, this slide shows an example for a NAND gate, how to write a module for a NAND gate. So, with the inputs, this NAND gate has the inputs, 8 inputs ranging from I1 to I8 and having only one output called as O. So, we are describing this particular gate level, we can call it as, with the help of a program. So, module with small letters, it's the keyword. Module name, it's the user defined. Then within the braces, we are going to declare the outputs first, followed by inputs. Output is O and the inputs are I1 ranging from I1 to I8. So in between, you can write the particular statements, 1, 2 or so. By instantiating this particular NAND gate, you can write the program at gate level, and you are going to end the module by its name called as end module. This is a simple example showing how you are going to write a simple module for a NAND gate. Now coming to another part of the Verilog program, which is nothing but the test bench, which is used to test the particular module here. The syntax for writing the module and for writing the test bench is quite differed. So here, this is the syntax that is used for the test bench, for writing the test bench. Module name. You are not mentioning any inputs and outputs within the parenthesis here, just only terminate with the semicolon. After then, you are going to declare the inputs and outputs. To declare the inputs, you are going to use the register, and to declare the outputs, you are going to use the while declarations. Then you are writing the stimulus, means you are going to give certain inputs with the help of initial block or always block, and then end the module. So here, while writing the test bench, always we have to remember that the test bench is always written in the behavioral modeling. Once we are going to describe any program, in behavioral modeling, we are going to have the initial blocks and always blocks. In the behavioral modeling, within the initial block, all the statements are going to be executed one after the other. Even in the behavioral modeling, all the statements are executed sequentially. So this is one. This is one of the example that shows how to write a test bench program. Here, the keyword is the module, and the module name is test. Within within the beginning and ending of the module, with the end module, you are going to have the statements. Either you can use the initial blocks or you can use the always blocks to give the set of inputs or stimuli. So this is a simple program that shows not the complete test bench program, but it shows how the initial block is being used here. This was the program that was written for describing the AND gate. This is the stimuli or the test bench program that is written for testing an AND gate. So you are using the initial block. Within the initial block, if there is only one statement, we can there is no need of using any begin and end. But if we are going to use more than one statement, then begin and end are being used. So here, as we are going to have number of statements, so we are going to start after the initial block. Within that, we are starting with the begin and then ending. In between, we are going to give a set of inputs at different time instances. So when we are going to see the first two statements where 0 is assigned to A1 and A2, here the time instances are not being described. Means automatically it will take 0 nanoseconds. Then at 3 nanoseconds, the value of A1 is going to change to 1. As we already said, within the initial block, all the statements are being executed sequentially. That means one after the other. So after 3 nanosecond, then the next statement when we are going to see, it shows #1, A1 equals to 0. Means at 4, 3 plus 1, sequentially it is running. So that's why the time instances gets added here. So at 4 nanoseconds, A1 is going to take the value as 0. Then at the instant of 6, means 3 plus 1 plus 4, 4 plus 2 becomes 6. So at 6 nanoseconds, A2 is going to change its value to 1. Like that, all the statements are going to be executed sequentially, one after the other, within the initial block. So after giving the set of inputs, you are going to end that particular module. That initial block is going to be ended. And you are instantiating the main design module by its name here called as AND. The gate, the name of the test bench program here, you are going to call it as G1. And whatever may be the port mapping that you have done in the design module, the same order you are going to use in the test bench also. B stands for the output here and A1 and A2 are the inputs. Then you are going to use another initial block. So since you are going to use only one statement, you are not using any begin and end. $monitor and $display, they are used to display the values onto the screen. You can view this particular $time, the value of A1, the value of A2, the value of B in terms of binary. Percentage B stands for the binary. The binary value is going to be shown for A1, A2, and then B. And you are going to follow the order here. First, A1 will be displayed, then A2 will be displayed, and at last B will be displayed. And then the next statement, when you are going to see the next statement, #100 finish. So you are completing this particular task at 100 nanoseconds. So it is going to be ended at 100 nanoseconds. So this is all for this session.